Welcome to this video on the topic of matrices. In this video, we'll be having a look at what is a matrix, and secondly, how we can organize them in a mathematical fashion. Now firstly, a matrix can be described as simply an array of information, or in simple terms, it's a collection of information represented together. Now if we turn our attention to the mathematics below here, what we have is a matrix defined as matrix A. If we look at the right hand side of the equals sign over here, what we see is this strange notation. So we've got some large square brackets, and inside we have all of these A's with this subscripting. So what we have here is a matrix. Now one of the first things that you might notice about this particular notation here is the way in which it's arranged. So what we see is we see the members, or elements as we like to call them, arranged in a grid-like fashion. Now the way in which we do this is we typically arrange a matrix in terms of rows and columns. Rows being the items that go up and down, or rows spanning up and down, and columns spanning right and left. Now if we were going to access particular elements or members inside this particular matrix here, what we can use is the subscripting method, each member or element. And we can say A, M, N. M being the particular row we're interested in, and N in green here being the particular column that we're interested in. We'll talk about this more in a little bit further on. Now on top of that, as well as being able to reference entire matrices using the uppercase convention, so A, what we can also use is a lowercase convention. Now this one's less typically used, but it's good to know nonetheless. So rather than referencing an entire matrix by calling it by its uppercase letter, what we can do is we can use the lowercase equivalent inside of two parentheses here. Parentheses being the curved brackets. Now going down, if we know how we lay a matrix out, then there's two things that we can deduce from this, that being the shape. So we can either have a square matrix or we can generate rectangular matrices. Now if we look at A over here, what we have is a square matrix. So we have a matrix defined by 3 rows, so going up and down, and 3 columns. Now for this sort of matrix here, we'd say that this is a 3 by 3 matrix. So 3 rows and 3 columns. Another way we can describe this is a order 3 matrix. Now if we go across to example B here, we have something different. We have 3 rows, but rather than 3 columns, we have 4 columns. So alternatively, what we call this is a 3 by 4 matrix. Notice how I've written it differently, so it's more succinct in how I've written it in this manner. Now this is going to be important in the coming lessons. Now if we're wanting to reference individual elements inside these matrices here, what we can do is use our lowercase notation followed by our subscripting. So if we're going to look at A21, so A21, what we need to do is first we need to look at the row, so row 2 over here, followed by column 1. In our case, we're going to be looking at 6. Going across, if we're looking at element 32 or member 32, what we need to do is we need to go to row 3, 1, 2, 3, and across to column 2, so 1, 2. This brings us to the number 4. Thus, element 32 is equal to 4. Now going across again, we have element B13. So instantly, we're no longer working with matrix A, we're working with matrix B. So we're going for row 1, element 3. So 1, 2, 3. So we're dealing with 11 now. So this is how we reference elements or members inside of individual matrices. Now the final thing we're going to look at is how we might go about constructing matrices based on this convention here. So notice how we've got Aij equals 2i plus j. What we're going to do is construct the 2 by 3 matrix defined by the equation below. So I meaning the row and j meaning the column. Now, if we know that this is a 2x3 matrix, what I'm going to start off by doing is simply by drawing my matrix up in advance. We're going to get 2 rows followed by 3 columns. So 1, 2, 3. Notice that I'm drawing this ahead of time. The reason for this is it's going to allow me to construct my matrix in a more cleaner method. So I'm not going to be messy when I'm writing this down. Now the next step is I need to start populating this matrix. So the first thing we want to do is get element A11. Now what is A11 going to be? Well, if we use the convention that we see in the equation over here, what I can do is I can go A11. In this case, I is going to be equal to 1. So I go 2, 1, plus 1. This is going to be 2 plus 1. And therefore A11 is going to be equal to 3. So therefore, rather than A11, I'm going to write 3. Going down again for A, we'll go 2, 1. Going down the row first, we'll go 2, 2 plus 1. This will give me 4 plus 1, and that will yield 5. Moving across, we have A1, 2. So row 1, column 2, get 2, 1 plus J is now 2, 2 plus 2, this will give me 4. Following on, and thus we're able to complete the matrix that's defined by this equation over here. Now, in summary, what we set out to do in this particular video is we wanted to have a look at what is a matrix, and we defined the matrix as being an array of information, and then we had a look at how we can arrange a matrix, that being either in a square or rectangular fashion, where the information inside the matrix or inside these square brackets here, we've referred to that as members or elements. The way in which we access them is using this subscripting method seen over here.